So for number 1, we needed to solve the equation. We have variables on both sides, constants on both sides. We need to move them so that the variables are on one side, constants are on the other. Someone raise your hand. What did you choose to move? So you guys can first. If that's not how you did it, then erase. Remember, you can solve these multiple ways. So since we moved our 10 to the right, we would now need to move our variables to the left. So we would subtract 6x. You have negative 2x equals negative 2. Divide both sides by negative 2, and you should have gotten that x equals 1. Again, you can solve it a different way, but you should have still got that same answer. Do we have any questions on number 1 before we move on to number 2? Yeah.
So like, which one to like add or subtract first?
So first, like the very first step, it doesn't matter. You choose whatever you want and you move it to the other side by adding a subtraction. After you pick one, that'll kind of tell you the other one. So in this case, since we moved, I have basically now decided that all of my constants that first step kind of tells you everything else.
Or so I did 4x.
That's fine.
But I got 0 equals 2x minus 2.
So the 0 here you don't have to put. But because you moved your x's over, you now have to move 12 over. Is that what you did? You're always moving opposite directions. And then we
Next switch?
Yes.
Okay.
For number 2, you needed to first distribute. This gave you negative 15 over 6. And then you could have simplified that. Divide both. Sorry, yeah, that's right. And then combine your like terms on the same side. So 5 plus 6 would give you 11. And then from there you have choices. Someone raise your hand. What did they move at that point? Yeah. And you added it to the other side? So 1/2 plus 5 over 2 would give you 6 over 2. So I'll write that first and then we can simplify it. 6 over 2 would just give us 3x. So now we don't have to worry about fractions and we can just solve for x. X should have been positive 6 when we did that. Or divided in this case, but either or, same thing. So if you started off by like moving 5 over or 6 over,
I
right?
moved 5 and then just like
That
they
works.
gave me the same answer.
Yeah, I was gonna say that works. Combining the like terms just makes it easier. But if you didn't see that those two numbers, you could combine and like you subtracted 5 or you subtracted 6 and then kept working, that's fine. Any other questions on number 2?
One question.
Yeah.
So, if if it's in fractions, you always divide.
Simplify if you can. Sometimes that's not the case. Like I can't simplify 1/2 anymore. But I could simplify 6 over 2. It just makes your life a little bit easier. Sometimes when you simplify like the 15 over 6, I could add these two together, but then I have to get common denominators or do it myself here. But when I simplify it, then we have the same denominator, so it just depends. Sometimes it makes your life easier, sometimes it doesn't. Number 3 was solved for you. Under solve this equation, and then you got this answer at the end. 2 equals 0. What type of solution would this be? Which it? And how do you know that? So either of those things. And really, if you got to this step, I wouldn't want you to do this part because you no longer have a variable, so you have nothing else to solve for. But that would be no solution. That does not look like there's no solution. I don't know what I spelled the first time, but that wasn't it. Questions on that one? Number 4 is a little bit more challenging than I really want it to be, but it kind of makes you think. You have the answer. Yeah, so I'm going to kind of walk you through how I thought about this, and then we'll talk about any questions. So first, I'm going to distribute this. Well, I'm sorry about that, but hopefully it'll make more sense. So I distributed. Right now, in my mind, what I know about infinitely many solutions is that if both sides are exactly the same, they're infinitely many solutions. Right now, I see that I have no -2, so that part's the same. But I see that this part is not the same. The x is, but the -8 and the 1/2 k is not. So what I'm going to do is kind of set those parts equal to each other and solve for k. So I know the 1/2 k needs to equal -8. So I can set those equal to each other. So when we have infinitely many right now these parts are the same. These parts are not the same. So I need to get them to be the same. The number in front of x needs to be the same. So in order to make them the same, I'm going to I didn't do that part yet. We set it equal to each other.
So now I'm gonna get divided by 2.
Not divided by 2, so you can divide it by 1/2 and you can multiply it by 2. Multiply by the reciprocal. Same thing as dividing by a fraction. You could also think about it as if 1/2 k needs to equal -8, I need to put in some number for k, and when I multiply it by 1/2, or if I divide by 2, will give me -8. And that would be -16. So from there, I could put -16 back into k just to see that this works. (1/2) times -16, or -16 divided by 2 is -8. And now they're identically the same. So I can say my k value is -16. So now it's infinitely many solutions, yes. So again, that one was a little bit more challenging than I really wanted, but it does get your brain working. Any questions on that one? Great. So you have your notes on your desk. The last set of notes we're going to do in this unit is solving absolute value equations. So all of our rules for solving equations, those still apply, but it's like an additional step when we solve absolute value equations. So when we do this, there's a couple steps we need to follow. First, we need to make sure the absolute value expression is isolated. What does that word mean? Alone by itself. So kind of like when we solve equations, we try to get the variable isolated by itself. We're doing the same thing with the absolute value expression. And then we're going to set the inside, so whatever is inside of the absolute value sign, we're going to set that equal to whatever number it says, but the positive and negative version of that. Remember that absolute value sign measures distance. So if I have -5 in absolute value, that's just telling me I'm 5 away from 0, both negative and positive in that direction. So I have to set it to both the negative and positive of whatever number it is. Once we have it set equal to both, we're going to solve both equations. And then we're going to write our answer as a solution set. So this part should be familiar from when we were doing range. That was a solution set. X1, X2, whatever the solutions are. Some of these start out really easy and then they get into harder examples. So for number 1, isolate the absolute value signs. There's nothing outside of the absolute value sign, so we don't need to do that. We can say, okay, check. Set the inside equal to both the positive and negative. Right now, the only inside is x. So we would set that to a +2 and a -2. Three was solved, but there was nothing to solve. It was just x. So we can write our answer as a solution set. Least to greatest, -2. Again, some of these start out very easy and then we move on to harder ones. Yes,
So it's just a variable. negative of the number and positive thing there.
Yeah.
These three.
Number 2 would be literally the same thing. Set this equal to both the positive and the negative. And then write it as a solution set.
Got it?
That's like a hundred.
We'll see.
Now,
Yeah.
for that one, where's the solution? Is that x
It's
and
x,
x minus?
it's x1 and x2. The 1 and the 2 are like subsets below the variable.
There's a 2 right next to it.
Yeah. So this one's a 2, this one's a 1. It's the x1. So for number 3, again, there's nothing outside of the absolute value sign. So we're isolated already. We're going to set the inside equal to a positive and a negative 40. Here we have to solve because we don't have just z by itself, so we have to divide both of these by 5. And then write as a solution set. I'm going to skip 4 and go on to 5. You could do 4 as with
Is it negative 40 divided by 5 or negative 40 divided by 5? Negative behind the line? Or is it behind the 40?
for this one.
Yeah.
When you say behind the line, I'm not sure what you mean.
The line that divides 40 by 5, is it behind that?
It's negative 40 divided by 5. For number 5, our absolute value sign is isolated. So we can set this inside equal to a positive and negative 8. And we need to solve both. Yes.
So minus 1 on both sides.
Yep. So subtract 1 on both sides. So all the ones we've done so far, they were basically the positive and negative of the same number, but that won't always be the case, especially if you have to add or subtract something. So number 6. Yeah. And I'm going to skip number 6 and move on to number 7. Again, our absolute value sign is by itself, so it does not need to be isolated. We can set this inside equal to a positive and negative 34. And to solve this, I would do what? Both. And then we need to do one more thing. Excuse me, one more thing. I first. And then you can put it in the curly brackets. Any questions so far? Like I said, it's like solving, it's just with an extra step. So far, this is not hopefully too complicated. Move on to the next page. If you want still need that one, I can go back. So if there's stuff outside of the absolute value bars, we need to isolate it. So I could build it, I thought you did. So for number 9, now we have something outside of the absolute value bars. So we're going to pretend that the absolute value bars and whatever's inside is like a variable that we solve for. We leave it alone until the end. So if this was like just C, I would subtract 2 to the other side. Once I do that, there's nothing else left on the outside of the absolute value bar. And when it is isolated, then everything else is the same. And then write your solutions up. Go down to number 11. Again, there is something outside of the absolute value bars. So pretend that this absolute value of x is just x. In order to get rid of the 6, we would do what? Divide. Both sides by 6. And then once those absolute value bars are by itself, we can set the x equal to a positive and negative 4. And put yours, or write your solution. Yes, yes, you're.
1. Oh no, no.
And then 12, 13, 14, for number 12, think about everything inside your absolute value bars as one variable. For when z plus 3 is all z, I'll worry about everything inside later. I know that's usually not how we work because we do the inside first, but in this case, don't do the inside first. So if I need to get rid of this negative 2, what would I do? Both sides by negative 2. The absolute value bars are now by itself, so I can now set the inside equal to positive and negative 7. However, in this case, I now need to solve both of these for z. So it has that extra step. Subtract 3 on both sides. Yep. 4 and -10. Have any questions so far before we get into some more complex ones? Okay. Let's do 13. For 13, my entire absolute value sign is being divided by 6, so I need to get rid of the 6 by doing what? Multiplying both sides by 6. Those 6's cancel. And then the absolute value sign on this side. And then now that your absolute value signs are by itself, then we can keep going. Set this inside to both a positive and negative 18. Now we need to solve both equations for W. That x equals 4. The 2W equals 22 and 2W equals -14. And then what? Divide everything by 2. I ran out of space, so I'm going to write my stuff over here. W equals 11 and W equals -7. Yes,
Are we dividing the 2?
say that one more time.
Are we dividing the 2?
Dividing. Once you get the hang of it, it's not so bad. It's just a lot of stuff. Especially with things that have things on the outside and things on the inside. It's a lot. So for number 14, we have to get the absolute value signs by itself. What would we do first?
By 10?
Not first. Think about this like -10 h minus
Add
3.
10?
Not add 10. Because the 10 is still multiplying.
Divide by that.
Divide by what? I'm sorry. So we wouldn't divide by -10 first either. Dividing would be the step to get rid of that 10, yes. But if I divide, I have to divide this by -10. This is not right down with this. This is -10, and then we end up with this fraction. We don't want that. Not that, but we would add 3. So you have to think about this like an equation. If it was just -10h minus 3, we would have to get rid of the 3 first. So the same thing here. You have to get rid of this 3 first. So now, what could we do? Divide by -10.
We literally divide by positive.
So whatever it is, we take that and divide it. You're thinking the opposite, but in this case, we would take whatever it is. Now we have finally isolated the absolute value sign. What would be our next step? You're like one step ahead. We will subtract 5. Jesse, were you stretching or were you? Okay.
Five equals 8 plus 5 equals -8.
Set this equal to both the positive and the negative. Then you could solve it from there. Then subtract this off. And -15. What else is there?
Does it matter in the solution set which number you're at first?
Whichever one is the lowest. Always right, least to greatest. Okay. That one had so many steps, and we'll see more problems like that. But do we have any questions on how we did any of that before we do one more of those types? We're going to do 16. We'll do 17, 18, and then I have one other that I want you to try, or that we're going to try. And then I'll let you guys practice. So for number 16, we need to get the absolute value sign by itself. What would be our first step? Add 24 to both sides. And then we'll
How
add
would you multiply each side by the reciprocal of
multiplied by 2/3. Three times 2/3 would give you what?
On the second, on number 16, is that a 11 or a 4? Is that
It's a 4, sorry. We get 2. These 3's really cancel. But you could also multiply across. 3 times 2 is 6. 6 divided by 3 is 2. So now we have the absolute value signs by itself. We could set this equal to a positive and negative 2. Notice that when I set it equal to a positive and negative, I no longer have my absolute value signs. Make that a habit. Make them disappear when you get to that step. Because what I don't want to happen is that you still have them and then you feel like you have to do the positive and negative thing again, or you do weird things and make like everything positive. Start solving, add 4 to both sides. I'm going to leave these as fractions, but you could If you need to know which one is the lowest, I would, if it's like a nice fraction, put it in decimal form, see which one is lower of the two, 1/2 or smaller than 3/2.
Good enough.
No, it just separated. So the steps are always the same. It just, the equation may change what you have to do. Sometimes you don't have to isolate the variable, sometimes you do. Sometimes you have to solve the inside, sometimes you do. Okay. For 17, if you were given something like this, where you had equals and negative, this is not something we can do. So if it starts off equaling a negative, that is not something we can do. And all of the problems where it did equal a negative, we solved it or isolated the absolute value. So somewhere along the lines, it became a positive, and we were able to continue solving it. Sometimes you're not sure, or you won't know that until you start solving it. So like for 18, I'll start isolating the variable. Divide both sides by -3. But then I would end up with a -7 on the other side. So now I can't solve this. Yeah.
So you can leave this one outside of the thing, it's no, it's on.
If it's on this side. If it's next to it, still isolate it first and then see. That's why when we set it equal to the positive and negative, we don't have the absolute value signs there, so we can actually solve it. Because if the absolute value signs were still there, when we set it equal to the negative, we wouldn't be able to solve it. If A is negative, we cannot solve it. There's a reason I don't remember where it was, so I'm going to put
Oh, because absolute values is distance.
Distance.
You can't have a negative distance.
Yeah.
So
Basically the reason. That's can't zoom in on that. So I'm not sure. But somewhere I have what it actually says. There was something like, or we could just write that. It's fine. Because distance, we can't take a negative. It can't equal a negative. Sure. When I figure out why that's not working, I'll get the actual definition of what it says. So we're going to do one more example. It's not but it can handle somewhere where you have blank space that may be like in the example box on the side, or in probably that would probably be the most space you have. I want you to write. Oh, that's not showing either. Okay. We're just gonna find a new problem. That's fine. Write this example down somewhere. We're not looking at them. So these will be examples we see like on Academy, and I wanted you to kind of see how to do this because it's basically when we get into it, it'll be solved the same way, but the like first step is a little different. Not something we've done. So if not all, but almost all of the Khan Academy questions will be set up similarly. We have like this on the side. So the notes we did on solving equations when there's variables on both sides, that kind of comes into play here. So what I'm going to do is, doesn't matter which side I like move this to. I'm going to take one of these sets of absolute value signs and move it to the other side. So if I'm thinking this one, then I'm going to move this one here. If I'm thinking this one, then I move that one here. What I want to do is get them both on the same side. That way I can combine them and then there's this one set. So if I move this over here, I'm going to add 7 absolute value of x plus 1 over to the right. And then I'm going to rewrite it. So this negative 5 comes down. This was already here. So and then put the other one that I had on the next to it.
You're basically canceling out.
Once they're on the same side, you can like combine like terms. Since this inside and this inside is the same, I could think about this as one variable and this as one variable. They have the same like variable, so I can combine them. So 2 plus 7 would give me a 9. One of the absolute value signs goes away, just like when we combine like terms, they become 1. And then it makes it easier to solve. But anytime you see problems like this, you'll have to get one on the same side, combine like terms, and then continue to solve. Say that again.
Then 5 is 12.
Yeah, so if I start solving this at 5, I get 0, which is fine. I would divide both sides by 9. What is 0 divided by 9? Yeah. So if you got something that canceled out, there is no such thing as a positive and negative 0. So this one you would only solve once.
That's just negative.
I think it would still ask for a solution set, and it would just look like this. Yes.
I did it with distribution, it says the, after the value signs are just parentheses, then I got this hand.
Okay, don't make that a habit, just because you might also do that when we're solving it regularly, and you might end up with the wrong thing. That may have happened to work this
It's
time.
just a coincidence.
Like combine it with that. You could, yeah. Okay. Any other questions? Bathroom. So for the rest of class, what you guys are going to be doing is going through the rest of the problems we didn't do. Towards the end of class, I'll show those correct answers. So problems 4, 6, 8, 10, 15. 5 problems. If you want more practice, I don't think it's up here, but I think you guys have another page attached to it of more practice problems. You can start those. You don't have to, but they're there if you want them. If you feel good after those 5 problems, you can start your Delta Math or Khan Academy. So do those 5 and then either work on Delta Math Khan Academy or start the additional practice at the end of your notes. Anyone have questions on what we're doing for the rest of the class today? Okay. You guys can go ahead and start working.